Hey guys, this is Test 60 Game 2. This is the television program actors game. It's an ordering game. We know this because the actors appear one after another, so there must be an order in which they appear. Now we have the 6 variables, G, H, J, L, M, and P, that we're going to place in order, and if you look at the rules, you'll see the same variables mentioned in multiple rules. For example, L is in both the first and second rule, H is in the first and third, M is in the first and third, G is in the third and fourth. So these rules link together, and we can create a long web of relationships between these different variables. So I'll just lay them out one at a time and connect them together as we go. So first we got that L and M are both earlier than H. So I'm going to put down, L and M both coming to the left of H, meaning they're before it. Then we've got L and P earlier than J. We've already got L here, so we can link P in. P and L are both before J. Now the next rule is a conditional rule, which is a little bit strange. You don't see this in most ordering games where we're loosely relating the variables together, but that's okay. We can still deal with it. We'll just write it to the side. So we've got when M is before P, then we will have H before G. So M before P requires H before G. Of course, we don't know whether that's actually happening. We can also take the contrapositive of this, though. So if H is not before G, because nothing is simultaneous, we know that, because they're one after another, therefore we know that H not before G means G before H. So when G is before H, then M is not before P, meaning that P is before M. Now, of course, these are not the only two possibilities for the game, but we can use these conditional statements to make two different main diagrams. Now, those two diagrams would not encompass all the possibilities for the game, because perhaps there's a case where we don't have M before P and we don't have G before H, and we wouldn't know what happens then necessarily. It would be a little bit more open-ended, but we can still make two different diagrams reflecting what happens when M is before P and when G is before H, two different diagrams to show that. So using this as our basis, when M is before P, what happens? So we'd have to just stick G in after it, right? So again, we've got P before both P before J, and we've got L before J, and then we've got L before H, and M before H, and before P, of course. So M would have to go before both P and before H, and then we'd have G coming after H. Now the thing is that we know that G can't go last because the final rule of the game says that, so I'll just stick G, not G, to the right here. G can't go last. None of M, P, H, or L could go before it, could go after it. Therefore, J would have to go after it. So we're actually going to have to modify this a bit to put J later. So I'm just going to stick J down at the end here. I'll get rid of J over here. And then we're going to have, of course, P before J as well. So we have the general order, L before H before G before J. Then we've got P before J and M before H. So a new diagram that's a little bit broader. I'll rewrite just to make it a little bit neater to show you what I mean. So there it is. I put G before H, and G before H required P before M, and everything else from the original two rules still holds true. Now again, I want to emphasize that these are not the only two possibilities for the game. They're just what it actually looks like when you take the sufficient and necessary conditions of each of these conditional statements and combine them together with the first two rules of the game, keeping in mind, of course, that G cannot be last as well. So these are not the only two possibilities, but they'll help us out a great deal. They also show us what examples of a couple of valid scenarios, and we'll use this over the course of the game. Anyway, question number 7 is a typical orientation question. We're just going to take one rule at a time and apply it to all 5 choices looking for violations. So the easiest thing to look for, of course, is that G cannot be last. So any choice where G does appear last is automatically invalid, and we can eliminate D because that features G last. We also know that we can't have any of PLM last, of course, because they're all coming before other guys. So any choice with PLM last is automatically gone. That gets rid of C where M is last. We can also look for either J or H being first, because that would help us get rid of things if we saw anything where they did appear first. Of course, only C was that where we already eliminated. So that's not going to help us either. We could use the conditionals when M is before P, H is before G. So scan through the choices looking for cases where M is before P. We see that in choice B, M is before P there, but we don't have H before G there. Therefore, choice B is invalid and we can eliminate it. Anything else? No, E doesn't have M before P, so we're good there. Let's look for G before H. So when G is before H, of course, P goes before M. Choice A has G before H, yet it does have P before M, so we're good on that issue. Choice C has G before H as well, and also has P before M, so we're good on that issue as well. Down to A and E, let's use these sequences a bit more. We know that P and L both have to come before J. And in choice A, we have J in between P and L. That's unacceptable. J has to go after both of those. Therefore, A is eliminated, and we get E for number 7. Next, number 8, general cannot be true question. So you could find the 4 things that could be true, eliminate them, and whatever remains would be your answer. Or if you see something that happens to work, just pick it and move on, of course. If you see something that happens to not work, just pick it and move on, of course. So could we have H before G? Could we ever have that? Yeah, this right here is an example of a valid scenario. If you just kind of put M and P into sequence complying with these rules, you could easily make a valid scenario. There's no reason that couldn't work. Therefore, A could be true and is eliminated. Looking at B, H appearing 6th, and of course, there are only 6 variables, so they're really saying H being last. Now, H could easily be last in this bottom diagram here. There's no reason we couldn't have everything else before it. Therefore, B is possible as well and is gone. L appearing 5th. If L were to appear 5th, that would mean, since there are 6 variables, we'd only have one thing after it. That can't work, though, because L's got to have both J and H after it out of a total of 6 variables. Therefore, the latest L could ever appear is 4th. C is impossible. Therefore, it's our answer to 8. I would look at D and E, though. P going before M could easily happen in this bottom diagram. No reason to think that couldn't work, so D is gone. And then looking at E, P being 2nd, that would simply mean that it has only one thing before it. And that could easily happen in this bottom diagram right here. We could have either, L before it, or we could have, maybe G before it. That could be perfectly fine, and everyone else would come after it, so E's gone, leaving C. Next, number 9, how many different people could appear 6th meaning last? Well, we couldn't have G last, so I'm going to cross that off. We couldn't ever have any of P, L, or M last, because they always got to have somebody after them. So P's gone, M's gone, and L's gone, leaving H and J. In this top diagram, we could easily have J last, and in the bottom diagram, we could easily have either J or H last. So we get, J and H is the 2 right there, so choice D for number 9. Next, number 10, if J was earlier than M. So that could never happen in this top possibility right here, where M is before P before J, and then M before H before G before J. So that's irrelevant. The bottom diagram also has, it's not really, J before M could potentially occur here, but it would still be really messy to try and work with this just because they're not near each other. So I'm going to start from scratch here. I'm going to put, we got J before M, and I'll put the other guys in around that. So we know that M is before H, so I'll tack that on right there. We know that P and L are both before J, so I'll put P before J and L before J. That's covering almost everybody. And let's see, we also got G, and we know that G cannot be last. Therefore, since H is currently last in line, G is going to be going before H, and G before H leads to P before M, but we already got P before M here, so we're totally good. And this is the diagram that simply results for number 10. Now they're asking us what could be the order of the other 4 people. So excluding J and excluding M, what could be the order? Well, we know we got to have G before H, so let's eliminate anything without that. That actually gets rid of C, D, and E, so we're doing pretty good right here. C, D, and E are all gone because they have H before G, and we need G before H. Then we got to have, P and L both going before H. And let's see, looking at A, we got P and L before H. Looking at B, we've got P before H, but L's after H. That's unacceptable, so B's gone, leaving A for 10. Next, number 11, if L was immediately before G. So on the top diagram here, that could never happen because we've got H between them, so the top diagram is irrelevant. In the bottom one, we could put L immediately before G, but that would be kind of messy. Oh, I don't know, we could play with it. I'm going to take G and put it right there. So we got L immediately before G, and G before H requires P before M, so this diagram does hold true, and this is the only relevant one, given that G before H does have to occur when L is immediately before G. So we're going to work with this right now. What must be true? G no later than 3. Well, could G be 4? We could have only two things, J and H, after it. So we could have maybe, P on 1, M on 2, LG 3, 4, J 5, H 6 interchangeable. That could work. Therefore, it does not need to be the case that G is no later than third. G could be fourth. A is gone. Next, looking at B, H appears last. That could easily happen here, and J could be second to last, perhaps. So B could be true. P doesn't have to be true, and that's gone. L no later than 3. Well, because we got to have G, J, and H coming after it, L could never be any of 4, 5, or 6. Therefore, 3 is the latest that L could appear, and therefore C is a must and is our answer. I will look at D, though. M coming earlier than G. Yeah, that's ambiguous. M could come before the LG box. It could come after. We don't know. Therefore, D is gone. P appearing first. Well, that could happen, but it doesn't have to happen because we could have the LG box coming earlier than it. Therefore, while P could be first, it does not have to be first. So for that reason, E is gone, leaving C. Next, number 12, if M appears first. So if M were first, obviously the bottom diagram is irrelevant because P is before M there. We're going to use the top one. And M before, M being first, of course, does require that M is before P. Therefore, this diagram is the only relevant one we could ever use for this question. And they're asking us what must be true. So must G be fifth? Well, G could be fifth if we had only J after it, but P could also be fifth. Therefore, G does not have to be fifth, and A is gone. Looking at B, H on 3, does that have to be the case? Well, we could have M, L, then M, then P, then H, so H could be fourth as well, therefore B is gone. Looking at C, J being sixth, yeah, everything else must come before J, therefore yes, J does have to be sixth, and is our answer to 12. I will look at D and E though. L being second, no, L could be first for all we care, so D's gone. Then looking at E, P being fourth, well, we could have P fourth if we had L, M, H, P, but we could also have, L, M, P, H. Therefore, H could be fourth instead, and P could be third. Therefore, E's not a must and is gone, leaving C.